Okay. So you've got these things that are kind of like, we'll call them function machines. Okay, so they're just mathematical models that we can kind of like input things into, and then it spits out outputs. I think maybe we talked about that a little bit yesterday. Okay, so they can all take on different shapes, and by that I mean kind of like the way they physically appear mathematically, right? So y equals 3x plus 1, right? That's a function machine, which you might recognize from grade 9 or 10 as being just a line, right? So a line would just be, right? You guys should have seen that. That's just a line, right? So that's the first function machine. It's a basic line, right? And then we take things, we input things into the function machine, and we get results of outputs, which come out the other end, right? So in this case, and for the case of this whole sheet that you guys are going to plug through, okay, is I'm just going to take my input values, I'm going to input them into the function machine for x, right? And I'm going to get out y's, right? So the function machine does, okay? It's just a function, right? So we put things in and get other things out that look different, right? So in this case, I'm going to take negative 2, right? So I'm going to go 3 times negative 2 plus 1, right? Which is going to equal to negative 6 plus 1, which is negative 5, okay? So there's your output, right? I'll highlight the outputs in blue, okay? Do we need a bigger? That better? Okay? It helps me a little bit too because I can fit things in a little better. Okay? So, it's almost as small as it'll go. Okay? So then the next input I'm going to put in is the negative 1, right? I'm going to input it into the machine. I'm going to get 3 times negative 1 plus 1. That's negative 3 plus 1, which is going to equal to negative 2. And so on and so on. 3 times 0 plus 1 is going to equal 1. 3 times 1 plus 1 is going to equal 4. And 3 times 2 plus 1 is going to equal 7. Okay? Right, so these are all your outputs, right? And then what you can do is you could have like a grid, right? You could have like an XY axis, right? Where I would just plot the outputs versus the inputs, right? So I could go, okay, well, I'm interested in knowing what this looks like, right? Which is probably the case most of the time. So what you can do is you can take your inputs, those are going to be on the x-axis, right? And you can plot them versus your y-axis, the outputs, right? So your inputs go along the red, and then the outputs would go along the blue, and each one would have like a unique spot in the graph, right? So for instance, I could go to negative 2 in the red, right, the first one, and the output was negative 5. So then it's way down here. That would be a point, right? And I could do that for all of them, right? And it would produce, I know that it produces a line. And you should actually maybe know that too, because that's grade 9 material, right? So I know it has to do, I can just plot another one. Let's go 0, 1, right? I know it has to do something like this, right? That's this machine right here. That's the picture that we get from that machine. Right? Does that make sense? And so function machines can just take different shapes, right? And they create different pictures, right? As we go. So if we look at the next one, a little bit more complicated, but same thing. All I'm going to do is take my inputs, right? And I'm going to get outputs, right? Just a little bit more complicated. The function itself looks a little bit uglier now, right? Right? A little bit more work, but it's still just a calculator exercise, right? I'm just going to plug things in, and I'm going to see what comes out the other end, right? So for the first one, I'm just going to go like this. Negative 2 squared plus 3 times negative 2, right? plus 2. And then I do each one of those steps individually. Right? So negative 2 squared is going to be 4. And then 3 times negative 2 is negative, like minus 6. And then plus 2. Which is going to give me 4 minus 6 is negative 2 plus 2 should be 0, right? So there's my output for this function machine. When I input negative 2, I get an output of 0, okay? So then if I wanted to graph it, I do the same thing. I go to my xy axis, right? Red would be along the x and blue would be along the y, and I'd plot them and I'd get a unique point, right? And then I could just keep going. Negative 1 squared plus 3 times negative 1 plus 2. That's going to be 1 minus 3 plus 2, right? Which is going to be negative 2 could be 0. Still 0. Okay. Interesting. Okay, then we keep going. What happens when I plug in 0? Right, I'm going to get 2. Because 0 squared is 0, plus 3 times 0 is 0, and then plus 2. 2 is the constant, right? So that's your like value when you plug in 0. That's what it comes out at, right? Okay, and then I could do this one. We'll just go through the rest of these to make sure everybody gets the right answers, and then I'll let you go and you can try working through these. Okay, but you can same thing. It's the exact same thing what I'm just showing you. Okay, and you can see any patterns. You're going to look for patterns when you start. Okay. Right, so 1 squared plus, so it's 1 plus 3 plus 2 is going to be 6. You could check that. And then I'm going to do 2 squared plus 3 times 2 plus 2. So it's going to be 4 plus 6 is 10 plus 2 is going to be 12. All right, so you can check all these outputs for yourselves. Make sure I didn't do it wrong, okay, for any given input. Okay. This you should recognize too from grade 10. This guy here, right? Do you know what that is? How many terms do I see? Terms. Just the terms, so individually. So things broken up by plus signs. 3. So what kind of polynomial is it? Trinomial. Good. Okay. So then you guys would have done a lot of work with factoring trinomials, right? So you would have maybe seen the man method, right? Where you had to find 2 numbers to multiply to something and add to something so you could break it down. Okay, we'll do that. It'll be later in the course, right? But that's the idea. Okay, I'm just trying to infuse some terminology into it too. Okay. So if I write it somewhere, you guys know what I'm talking about. Okay, this is new, unless you've taken the 2D. You wouldn't have seen this form of a quadratic. Okay? I know it's a quadratic because of the 2, right? But you can do the same thing. So I'm going to input stuff into my function machine. I'm going to get outputs, right? So this one's just a little bit uglier because I got to follow rules, right? So I'm going to plug in x, right? The inputs are going to go in, and I'm going to get outputs out, right? So I'm going to plug in x's, so negative 2 minus 1 squared plus 1. So I have to do the inside first, right? Which is going to be negative 3, right? 2 times negative 3 squared, running out of room, plus 1, which is going to turn into 2 times 9 plus 1, which is going to be 18 plus 1, which is 19, okay? That was a little bit uglier. Not a nice function machine relative to the one that looks like a line. Okay? You guys want me to do that one? I'll finish it out. -1, -1. I'm just going to write the answers. You guys can check, okay? But it's the same thing over and over again. We're just going to keep plugging in x values to get out y's, right? Inputs and outputs, okay? So I'm going to plug in -1 for x. -1 minus 1 is going to be -2. -2 squared is going to be 4 times 2 is 8 plus 1 should be 9. I did a lot there. You guys are just going to do the same thing that you did there, right? And the one above. I just did it all in my head. Okay. 0 minus 1. So I'm inputting 0 here. 0 minus 1 is -1 squared is 1 times 2 is 2 plus 1 will be 3. Okay. The next one's kind of easy because I'm going to input 1 for x. 1 minus 1 is 0. Right? 0 times 2 is 0 plus 1 should be 1. Okay. If I make a mistake or somebody catches something, just tell me, okay? It's very easy to do this. I prefer to write it, and I would if I had a little bit more space, but this is what it is, okay? 2 minus 1 is 1. 1 squared is 1 times 2 is 2 plus 1 should be 3. Okay, you guys can check all those. Okay. Do we have any crazy questions? What happened? I tried to do my best there to convey all that. Okay. Any function you see, it doesn't matter what it is. Okay. It doesn't matter how complicated it looks like. You can always produce a table of values by plugging things in and getting outputs out, and then you plot them. You get a picture. You can always do that. Okay. So you guys